Hello to all dear and clean energy enthusiasts. Welcome to Fixed Focus program. Hope you all are doing well wherever you are. Today I want to start building a larger solar dish for the fixed focus system. Although this solar dish is small, we did various tests on it. The surface of this solar dish is less than 1 square meter, and we will change this dish in future plans. And for this we need to make changes to the system. If we choose a bigger solar dish, the tests can be done better and easier. So, in this program, we want to start making a square dish. Circular dishes do not have corners, and this part has been removed. So we want to have a square dish to use the maximum system surface and not waste energy. In the fixed focus system, the path of the solar dish can accommodate a square dish. In this figure, you can see that the energy concentrated in a square dish is approximately 1.27 times the equivalent circular dish. Of course, not every type of dish can be mounted on this system, and it must have its own specifications. For example, it should have a groove for the focus base and edges as a central support. Of course, we should make a dish that can work for us for at least 15 years. However, this work is a difficult task, especially in winter and in this cold and rainy weather, and if you want to do this work, you must not forget to be careful in your work. In addition, we can also use solar flat dishes, and it is relatively easier to make, but the main problem of flat dishes is that it is not possible to wash its surface easily. And I plan to make a solar dish with a surface of 1.6 by 1.6 meters, in which case its area will be 2.56 square meters. Of course, I made the design for a 3-meter dish, the length of one side of which is 1.8 meters, but due to the need for many system changes, I reduced its length to 1.6 meter. In this figure, we have a dish with a side of 1.8 meters, which is a part of a sphere with a diameter of 4 meters. This figure shows the central cross-section of the sphere, shown as a circle. If you look carefully at the figure, you will notice the calculation and design. Making this type of dish is not an easy task because it requires both precision and patience. Those who want to prepare a solar dish with this method should watch this video carefully. So first we have to find a suitable environment for this work. Are you ready to go to start a tough work? Well, now I have prepared an environment for making the solar dish mold. The width and length of this space is almost suitable, and if it is bigger, it is much better. I put a plastic under the work so that it can be collected easily if the plaster spills. To shape the mold of the dish, I already prepared a tube with the required length. This metal tube is bent with radius of 2 meters, so the focus distance of our dish will be 1 meter. The distance from this part of the pipe to the other end is 2.30 meters. So we can start working with this metal pipe. First, I put on work gloves. I made an iron base, as you can see. I have placed 2 bearings in this part. One is here and one is here. Of course, you can weld the threaded rod in the center of the tube instead of the bearing. Now I place this stand in the center of the work environment. Two washers. And now I put the tube that is pierced in the middle on the screw rod. You can see that the rotation of this tube draws a part of a sphere. We have to fill the entire part under the tube to prepare the mold, and the volume will be really large. If we want to use plaster, we need a lot of plaster. The first method is to use foams available in the market. We can cut foams layer by layer and fill the volume. But the second method is that if you have access to a suitable hill, you can insert the rod at the top of the hill and into it, or prepare an artificial hill. But maybe someone does not have these facilities and wants to have a permanent format. See figure for understanding. So we go to the third method and use rib lath sheet. It is a rib lath sheet which is both cheap and light. In fact, I want to leave the space under the pipe empty. For this, I use a metal ring with a proportional radius that is welded to the tripod. The main base should be placed in the center of this ring, and I will try to place the ring in the right place with the meter. It should be noted that most of the weight of the mold is on this metal circle and its bases. Therefore, it must have adequate strength. To place the rib lath sheets, I made a series of metal wires that I welded to the center of an iron sheet and put the hole in the center on the base. These wires, which are 8 in number, provide a support for placing rib lath sheet. I fasten the metal plate with a metal nut so that it does not move. Now we place the rib lath sheets on it in proper order. We tie the rib lath sheets to the ring with a metal wire. Now we have to put a plaster coating on the rib lath sheets. But we cannot put the plaster directly on the rib lath sheets because it will cause the plaster to fall out of its holes. Of course, it is possible in places where several layers of rib lath sheet are on top of each other. This is the first time I want to put plaster on rib lath sheet. I saw a method in a movie related to suspended ceilings partition that was interesting, and we will implement it. First, I will put this piece of foam here. I have prepared some pieces of plastic sack and put one of them on the foam. Now I prepare the plaster and put a thin layer of plaster on the plastic sack and put it slowly on the rib lath sheet. After the plaster dries, the plastic sack is easily removed. I will do one of them and see if it can be done. We put a thin layer of plaster on the sack. It is better if it is watery plaster that I need some more. And in this way we place it on the rib lath sheet and let the plaster harden. I take the video camera to the original place and continue the work. Well, almost the plaster coating is done. And now we can do the main plastering. Let's use the bent pipe and do the plastering. Let me tell you one thing, and that is that the plaster we used for the metal mesh is a type that hardens very quickly. And the plaster that we use later is of a type that hardens slowly. Of course, for the speed of work, you can also use plaster in both cases, which hardens very quickly, but you must work faster. Well, let's go to the next step. Before using the bent pipe, I want to mark the dimensions of my work with this bent iron angle. I put it on the work and on two sides and mark it with spray paint to determine the area of plastering. Well, I welded an iron cylinder to a washer, and with this I want to create a support for a better placement of the bent pipe. Also, this will prevent the plaster from hitting the center of the rotation. So that the plaster does not stick to the pipe, I have greased the pipe with grease. For easy movement of the iron tube, I made a hole in one side of it, and by tying a wire of suitable length, you can move it easily. Well, let's go to casting plaster. Try not to make the plaster thick, rather, the plaster should be properly diluted so that it can be easily shaped. in this way that I prepared. Be sure to start pouring the plaster from the top because it makes the metal pipe have a proper support for movement. Let's go to continue working. Well, the plaster mold work is almost finished and there is some putty work that I will do later. I will open the tube and tell you a few things. The first point is that you should be careful that the pipe does not change due to the pressure of the movement on its bending work. It means that the pipe should not come out of that initial bend. To make sure that the bend of the pipe has not changed, we draw a circle on the ground with the radius of the bend of the pipe. Then we put the pipe tangent to it to make sure that the original bend of the tube has not changed. As in the figure you see. The second point is that the change in bending occurs more in the central part of the pipe that is perforated. So that this problem does not arise, you can weld on the pipe from an iron corner with a suitable bend, and with this, the pipe will be more resistant to bending. Place an iron corner on the pipe like this and weld it to the pipe and create a central hole on the corner. In this case, the metal pipe will have more resistance. Another point is that it is better to clean the pipe at each stage of plastering. You can easily do this with an iron wire. Like what I do. And in this case, you will see that the part under the pipe is completely cleaned. Well, I'll work on the plaster mold some more, then let's go to the structure of the solar dish. Well, now we have completed the plaster mold and we need a metal frame for the surrounding of the dish. And it depends on your work, but I want this dish for a fixed focus system. Because I want the solar dish to be square, so its frame consists of 4 iron corner pieces. The important point is that the bending radius of these sides is less than 2 meters. And has its own calculation. Now, if this is a side of this square, its bending radius is less than 2 meters and this radius is approximately 1.83 meters. In the figures you see, this issue is clearly defined. If you look carefully at the figure, it is completely understandable. Well, I'm going to put these sides in the 4 corners. I will put the camera in a suitable place. Because this solar dish is designed for a fixed focus system, so a part of the dish should be considered to pass the focus base. And this is how I made it. Since this part is in the center of the dish, it should be bent to a radius of 2 meters. And it should be placed here. Between these iron corners, I use small and light metal cans and weld them together, and this makes the dish more solid. Unfortunately, the time of the video has increased more than usual and the most difficult part of making the solar dish is done. And so you will see the second part in the upcoming program. So goodbye until the next program.